Greetings and welcome to another lecture in psychopharmacology where we will be covering non-medicinal biological treatments. We already covered the talk therapies and the behavior therapies, and we covered the medicinal treatments, the antipsychotics, the anti-anxiety drugs, and so forth. So what we're going to be covering here are the non-medicinal treatments that are still biological. And they include electroconvulsive therapy. Now, electroconvulsive therapy had a terrible reputation that was in part well earned. It used to be called electroshock therapy or just shock therapy. And it began to be used because of the finding that a seizure oftentimes caused people who were depressed to feel better, at least for a while. The researcher who discovered this started working with people who had diabetes back before there was insulin to manage to keep people from going into basically a diabetic seizure because of too little blood sugar for the brain. And what he found was that the people who survived that and came out of it oftentimes felt better. So he decided to work with something a little safer and started to work with electricity instead. Now, in the 40s and 50s, electroconvulsive therapy was used for everything, under the the well-known rule of thumb that if all you have is a hammer, then everything looks like a nail. Basically, there weren't good drug therapies. Most of the talk therapies didn't seem to work very well, so they used this for absolutely everything. And needless to say, it didn't work for absolutely everything. It didn't work for a lot of things, and so people wound up with some problems. It also was overused. People would get multiple sessions a day. People would get lots of electricity through both hemispheres of the brain. People were not anesthetized during. It was a horror show, essentially. Nowadays, it's done very, very differently. Nowadays, it's done maybe 3 times a week instead of 3 times a day. There's much less electricity. You don't need to shock the bejesus out of people to do this. There needs to be just enough electrical current running through one hemisphere of the brain to start basically to disrupt the brain activity, which is what a seizure is. People don't have to be flopping around, so they're given muscle relaxants. It's the brain activity that's important, not what the body is doing. Also, this is something that is used as a last resort these days. It's used mostly for severe and or suicidal depression that doesn't respond to anything else. There is some use of it for people with bipolar. There's been a bit of use of it for some people with schizophrenia, but on the whole, it is a last resort because it has such a bad reputation, and because it's another one of those global. It's a global treatment. We have no idea why this works the way it does. Why a seizure somehow seems to make people feel better, although we're fairly sure it's not because people say they're feeling better so they don't get given another seizure. Bad joke. But we don't know how it works. We don't, except that we know that in an awful lot of people where nothing else works, this works. The major side effect nowadays, now that it's not given as often or as strongly or that sort of thing, is memory loss. And this is indeed a major side effect, and for a few people, it's a traumatic side effect. There have been reports of people who have undergone this that have quite literally lost years of memories. But for most people, it's temporary. They lose the memories for what happened right before and right after the treatment, but all the rest of the memories usually come back over time. And if you're thinking to yourself, this sounds similar to a brain injury, you would be right. In fact, the pattern of anterograde and retrograde amnesia that one finds in electroconvulsive therapy is very similar to that you see in someone who has received a head injury. And so this is another reason why it's a last resort. This is not something that is, going to be done flippantly, because there is a possibility for major side effects, but there is also a possibility that this can help people who are literally at the end of their rope. Transcranial magnetic stimulation is much newer. This is in the last, 10, 20 years. And what this does is it uses magnets over the skull. It's not invasive at all. It's like electroconvulsive therapy in that way. It uses magnets to create a field to change neuron activities. Now, all neurons have, bits of iron in them. They all respond to magnetic fields. That's how MRIs work, is they cause different cells made of different components to basically show up differently on the scan. And so here the idea is to use the magnets to change, not to get a view of what is happening, but to get an idea of how things are working, or to change things, actually, to change the behavior of the neurons. Because this is non-invasive, it's possible to target the area very, very precisely. So this isn't like electroconvulsive therapy where they just, do a global seizure in the hope that it'll help one little part. Here they can just use the magnetic fields to affect the one little part. And what's interesting is that this works really well for major depression. That for people with major depression, if parts of the brain are basically given this different electrical field, it really does make people feel better with very few side effects. There certainly aren't the memory loss side effects or the problems with the drugs and their side effects. It really does seem to be something that we may see more and more of, because it's a lot closer to that perfect treatment, which works well for most everybody. We don't know that yet, but we will soon. And it has very few side effects, which it certainly seems to have. The other non-medicinal biological treatments I'm going to be talking about are various types of neurosurgery. Neurosurgery is sometimes called psychosurgery. It's basically actually doing surgery on the brain, which is it's something you don't really want to do if you don't have to, because the brain is very well armored for a reason. It's very well protected, because when you get in and you start cutting neurons, they don't grow back. If you start damaging things, they don't return. And this can be a real problem. The sort of traditional neurosurgery, other than trephining, which is its own special little horror, is the lobotomy, also known as the prefrontal lobotomy. The lobotomy is technically described as a surgical disarrangement of the frontal lobes, which tends to make people think, what we're going to do is we're going to go in and there's going to be surgery in a sterile field, and we'll open up the skull and we'll go in and just remove certain parts of the brain and put everything back. No. Generally, lobotomies were done with no more equipment than anesthesia, antisepsis, a hammer, and an ice pick. In fact, one of the big proponents of lobotomies, named Walter Freeman, who used to travel around in what he called his lobotomobile, not kidding, was a doctor who would essentially go to people's homes and do lobotomies while you wait. And all he needed, as I said before, his lobotomobile was tricked out as a mobile surgical suite, or he would do this in the comfort of people's own homes. People who were getting lobotomies would be anesthetized, and the doctor would very carefully work the gold-plated sterilized ice pick around the eyeball. Sorry, this might be too much information. You may want to skim forward just a little bit. Around the eyeball to the back of the eye socket, use the hammer to hammer in through the back of the eye socket, which is one of the places where the skull is relatively fragile, and then basically work it up and down, move it up and down, and when you move the handle up, of course, the point goes down. So he was basically whisking the frontal lobe, and then he'd carefully remove it from that eye and do the other one around the eyeball into the back, hammer, whisk, remove, and the person would be left with two black eyes and a scrambled frontal lobe. And somewhere between 10 and 20% of the time, they would die. This was a high-risk procedure. For those who survived, needless to say, they changed. Some people simply became catatonic. It was usually done when someone was behaving wrong. For schizophrenia, they were. But then again, it was also used, on children who were misbehaving at school. This was just my God. This is another one of those all I have is a hammer things. And literally, in this case, there was indeed a hammer involved. Other people would become completely out of control. It was the equivalent of trying to kill a fly with a hand grenade. Yes, you would kill the fly, but there would be a lot of collateral damage, shall we say. And so, we've learned much better methods than the equivalent of hitting someone in the forehead with an axe. Lobotomies have not been done in the United States since the mid to late 1960s, and I'm not entirely sure they've been done anywhere else since, simply because doctors came up with much better ways to try to treat these things. Nowadays, if a part of the brain needs to be destroyed because it's causing seizures or because something else is going wrong, very often it can be treated with lesioning. And the idea of lesioning is that the area that needs to be removed, the area that's causing a seizure, for instance, that needs to be removed, or a part of the thalamus that needs to be removed for some people with Parkinson's, is that part is pinpointed while the person is awake. You need to be awake for brain surgery. They basically anesthetize the scalp and screw their head into a vise so that they can't move. And then a hole is drilled in the skull, and one electrode is very carefully threaded through the brain until it gets to the point that needs to be lesioned. You don't want to go in with a scalpel and start whacking, because, of course, the neurons that you cut will not be replaced. So they very carefully wiggle a very, very small electrode at the end of a very, very thin wire in until it gets to the appropriate spot. And they check that with x-rays, to try to make sure it's in the right spot. They talk to the person. Usually what they do then, before they actually remove the area, is they talk to the person. They talk to the person while they're running a little bit of electrical current through that electrode that will stimulate that brain area to make sure that area isn't something important. Because there have been too many cases of people who've had brain areas removed, and only afterwards was it discovered that those brain areas were pretty darn important. I give you HM of the famous missing hippocampus. And anyway, if the area is found to not be that important, then a larger burst of current is run through, and that little area is burned out. And the electrode is then carefully removed, and that area has been destroyed with minimal damage to the surrounding areas. It's also possible to use electrodes in much the same manner to stimulate certain parts of the brain. I mentioned this possibly being done to replace the deteriorated substantia nigra in people with Parkinson's disease. And that it may be possible, and it's been done in sort of a probe test where they will run an electrode to the part of the brain the substantia nigra runs to, and then run a constant mild current to there, replicating the effect of the substantia nigra, and it does tend to reduce Parkinson's symptoms. It's still in the test phase, but it's a potential treatment. Again, it doesn't necessarily fix it, but it does hopefully reduce the symptoms. Now, if we wanted to fix it, there was the other treatment I brought up when I was talking about Parkinson's, and that was stem cell treatment. Stem cells are cells that are undifferentiated. As I've mentioned before, your entire body came from one fertilized egg, from one cell, that divided and divided and divided and differentiated and differentiated until it eventually became all of the different body types that make up your physical being. So one of those cells, those stem cells, has the potential to become anything. The best stem cells, the most useful ones, the most flexible ones, do tend to come from fertilized eggs. And a lot of people have ethical issues about using fertilized eggs to treat other individuals. And others don't necessarily have that problem. You can get stem cells from other places. Umbilical cord blood has some stem cells in it. Fat actually has some stem cells in it. But generally the ones from fertilized eggs are the best. I'm surprised someone hasn't come up with a way to just take one egg away from like a 16 cell fertilized egg, and that fertilized egg can then go on and be implanted, and it'll grow perfectly normally without that one cell, and use that cell, probably because there aren't enough cells that way to get enough to do a treatment. But there has been some preliminary research using stem cells to replace not necessarily brain, because brain is far too complicated. That cell would have to replace all of the different connections that each neuron has in the brain. And one neuron in the brain can have thousands of connections. So that's pretty much going to be impossible. But pathways, like the spinal cord, like the substantia nigra, pathways may well be able to be replaced by putting stem cells into the area of the pathway and seeing what happens. This has been done with a few patients with Parkinson's, and generally their symptoms have improved. So it was assumed that the stem cells took the place of the damaged or destroyed substantia nigra cells. But this treatment is extremely preliminary. It has not been done large scale yet. I suspect it will be in the next 15 to 20 years, depending on how many more pandemics get thrown our way. So it may very well be that as you age or as your children grow up, we may be able to use stem cells, hopefully ethically sourced ones, so that everyone is happy in order to treat disorders in the future.